In this video, I'm going to be talking about accumulation. And so we're going to be looking at the fundamental theorem of calculus in maybe a little slightly different way than we looked at in the last unit. And I'm going to also be recording a separate video on the application problems that show up on this. And it's always showing up on the free response section of the AP exam. So we're going to look at those rate in, rate out questions next time. And I'll have a separate video for that. So for now, we're going to start with the fundamental theorem of calculus. We know that we take an integral for ease. I'm going to make the integrand just the derivative. We know we take this by anti-differentiating, plugging in the top bound, plugging in the bottom bound, and subtracting. But today what we're going to do is we're going to look at this a little differently. We're going to add f of a to both sides, and so we're going to have f of b equals f of a plus the integral from a to b of f prime of x dx. And now I've said this before, probably in a different video, but I really like this form because it really calls back to the end value is given by the starting value plus the accumulation of some rate of change. So here's a problem that we might have actually even solved 2 units ago when we were studying differential equations. This was a thing that we could find by taking an antiderivative, solving for the value of c, and then plugging in x equals 4. So why don't y'all do that? Just remind yourselves of how we did that. Find an antiderivative with plus c, find the value of c, then find f of 4. And if you're watching at home, you should pause the video right now, because in like 5 seconds, it's just going to come up with the answer. Alright, there you go. So I took the antiderivative, and the antiderivative of 4x is I'm going to increase the power by 1 and get x squared and divide by the new power, so I'll have 4 divided by 2 is 2x squared. Then the antiderivative for 2 is 2x, and then I'm not going to forget my plus c. Then I plug in 3 for f of x and 1 for x, and I conclude that c is negative 1. And then when I plug in 4 to f of x, I'm getting 39. Okay, now we're going to do this exact same problem again, except we're going to do it with f of b equals f of a plus the integral from a to b of f prime. So I'm just going to write that again. Okay, f of b equals f of a plus the integral from a to b of f prime of x dx. So in this example, we'll have f of 4, that's what we're looking for, given by f of 1 plus the integral from 1 to 4 of f prime of x is 4x plus 2 dx. Okay, so this is f of 1 is 3, so I'm just going to change that to 3. So I'll have 3 plus, okay, and antiderivative for 4x plus 2 we found was 2x squared plus 2x. I can plug in 1 and 4. So this is 3 plus 2 times 16 is 32, plus 8 is going to be 40. And then when I plug in 1, I'll get 2 plus 2 is 4. So I've got 3 plus 36, and I'm getting 39 again. Okay, so we see it works both ways. It doesn't matter how you look at it. Okay. But in general, this is going to be much more convenient, especially for things that we're going to need to use a calculator for. Okay, here we've got another one. So I'm going to kind of set this one up, and then, kind of have y'all take it the rest of the way. So I'm going to say that f of 6 equals f of 1 plus the integral from 1 to 6 of f prime of x dx. The thing is, what's an antiderivative for x squared e to the x? Yeah, that kind of looks hard. Yeah, the thing is, we don't have a product rule for antiderivatives yet. We will in January, okay, but we don't have that yet. So for now, we need to use a calculator for this. So, and here's a calculator. So I'm going to say f of 1 equals 5 plus the integral, and remember we get the integral with math 9 from 1 up to 6 of f prime of x is x squared times e to the x with respect to x. Oh, no, that's not what I wanted. I want the x. There, yeah. And then I come over here and I'm going to have it do the work for me. And then I get, wow, f of 6 equal to 10,491.430. And we always round to 3 decimal places. And this actually kind of makes sense to me because x squared e to the x, that's just growing so fast between 1 and 6. 36 e to the 6 is going to be huge. And so, you know, I'm seeing this as a valid answer. And then when they ask you to find the y-intercept, well, this is a good question because it would be tempting to try to find an antiderivative and then plug in 0, right? That would be kind of what I would first expect to do. But it's like, wait a second. The y-intercept is the value of f of 0. And maybe I could just use the same fundamental theorem that I've been using to kind of count backwards on the derivative and figure out, recover values of f, earlier values of f, just based on the derivative, because we have equation for the derivative. It's telling you how the function acts, so we should be able to use that to draw conclusions about f. And over here, I'm going to say that, all right, f of 0 equals f of 1 plus the integral from 1 to 0 of f prime of x dx. And so I'm going to go over here, and maybe I'll already know about this, but if you press second enter, it's just going to call back to the same thing that you just did. And so I'm going to do that because it's still going to be 5, except it's going to be the integral from 1 to 0 of x squared e to the x. Press enter and we get 4.282. Point being that we can also go backwards on this as well. And it still works the same way. You don't have to worry about the fact that, you know, we're integrating from 1 to 0. If you think about it, if the derivative is positive, right, it should be increasing. And the integral of a positive function is positive. But if it was increasing, as we go backwards, we should get a lower number. So we should end up subtracting a positive. So it does make sense, if you think about it. Great. Here's one for y'all to try on your own. So y of x is a curve with derivative given by 6 square roots of x. Y of 4 is equal to 3. Find y of 9. So y'all do this one. And if you're watching at home, you can just follow along with me. Here, so I got 79. And this is one that we can do by hand. You know, it's the type of question that we might be asked to do by hand. It's really not too bad. It's all in the setup. It's all in the setup. next we've got a particle motion problem. So the velocity of a particle is given by v of t, 6 sine t. The initial position of the particle is -3. Find the position of the particle at time t equals 2 pi over 3. And this one, you know, if I were to, say, ask this question on a quiz or something, I would say, give an exact answer, which is code for don't use the calculator. Because the calculator is not going to give you an exact answer. Unless you have a TI. And then, so, x of 2 pi over 3 is equal to x of 0 plus the integral from 0 to 2 pi over 3 of x prime of t dt. Well, what's x prime of t? What's the derivative of the position function? Yeah, it's the velocity function. So I'm going to actually just change that out for v of t. And then, so this is equal to -3 plus the integral from 0 to 2 pi over 3 of v is given by 6 sine t. Okay, so 6. And so this is going to be -6 cosine of t as t runs from 0 to 2 pi over 3. Okay, cosine of 2 pi over 3 is -half. Yeah, it's not very far over. And cosine of 0 is 1. Okay? And, you know, this is another one where we could, you know, do the arithmetic, but so many of y'all made that error on the test. You know, it's so sad. You know, you had it here correct, and then you did some arithmetic, and something bad happened. You ended up with the wrong answer. I can only give you half the credit. It's the worst when that happens. So let's just stop there and be happy. Okay, that's the position of the particle. Okay, the next thing we've got is one from the 2006 Calculus AB exam. It was number 6, particle motion. For t between 0 and 12, a particle moves along the x-axis. The velocity of the particle at time t is given by v equals cosine of pi over 6t. Particle is at position x equals -2 at time t equals 0. Now, one thing that y'all need to know is that number 6, I think at this point, maybe there were in 2006, there might have still been 3 calculator and 3 no calculator. Now there's 2 calculator. The first 2 are calculator, and the last 4 are no calculator. But either way, this is a no calculator question. And you can see this is a pretty nice and anti-differentiable function, so it shouldn't be too bad. Find the position of the particle at time t equals 4. Well, that's something that we can do. X of 4 is going to be equal to x of 0 plus the integral from 0 to 4 of v of t dt, okay, which is going to be -2 plus the integral from 0 to 4 of cosine of pi over 6t dt. Now I want y'all to take this integral yourselves. Right, this one, it's got a little bit of trick to it because of that pi over 6, and so I'd like to see what y'all come up with. And if you're watching at home, you know, you're going to want to pause the video because I'm just going to come straight with the answer. All right, so what I did, I took an antiderivative for cosine of pi over 6t, and an antiderivative for cosine is sine, so it'd be sine of pi over 6t. But I need to prepare for the chain rule by, you know, dividing by pi over 6 or multiplying by 6 over pi, so that when I take the derivative of sine of pi over 6t, the pi over 6 will multiply with 6 over pi and make 1 cosine of pi over 6t. Okay, so I have plug in 4, and I have sine of 4 pi over 6, sine of 2 pi over 3. 2 pi over 3 is pretty high up and a little bit to the left, so pretty high up is sine equaling root 3 over 2. And so I have 6 root 3 divided by 2 pi. You could call that 3 root 3 over pi. Whatever you want. And then we're still adding that -2. Okay. Real quick, we can find the times at which the particle is moving to the left. That's where v of t is negative on 0 to 12. So there's 0, there's 12. let's see, cosine of 0 is 1. Cosine of 2 pi is also 1. And it seems like, okay, I'll just go to 6, because that might be a natural place to go. Cosine of pi is -1. And it just looks like we're going to kind of graph one period of cosine through here. And, okay, where are the zeros? Where is cosine equal to 0? Cosine is equal to 0 at pi over 2 and 3 pi over 2. So pi over 2 is 3 pi over 6. 3 pi over 2 will be 9 pi over 6. And it appears that v is negative through here. So that's 3 is less than t is less than 9. And then finding the time at which the particle is farthest to the left, we would need to find the absolute minimum. Okay, now, I believe that's going to be 9, right? Because I see that here we're moving to the right, moving to the right, moving to the right, and then we're doing a lot of moving to the left, and then we turn around and start moving to the right. So I would think t equals 9. But I would recommend using the closed interval test for that. In the interest of time, we could just kind of move on. All right, we've got another particle motion problem here. T ranging from 0 to 6, particle moving with velocity 2 sine of e to the t divided by 4 plus 1. That's looking like something we're going to need to use a calculator for. AB number 1, the first question, definitely calculate. So, position not explicitly given. But if we have an initial condition in the velocity, we can recover any kind of position information we need. Is the speed of the particle increasing or decreasing at time equals 5.5? Now, this is something that we need to talk about again. Speed increasing versus speed decreasing, speeding up, slowing down, that type of thing. Okay, so I've entered v of t into y1. And we remember that if we're asked if speed is increasing or decreasing, we need to check the sign of both v and a. So what I'm going to do is I'm going to quit for a second. And I'm going to find what is v of 5.5. Well, I'm going to call on y1 and plug in 5.5. And remember that TI-83, TI-84, it's smart. It knows what you mean. It's like v of 5.5 if v is y1. So you plug it in and you get v of 5.5 is negative 0.453. A of 5.5. Well, what you need to tell them, how are we getting this? So this is going to be v prime of 5.5, which we're going to find using math 8. Okay, so I go over here, and I call on, there it is, math 8 to ask for a derivative. And please take the derivative of velocity, which I've stored in y1, at time t equals 5.5. And we get negative 1.386, it looks like. Bless you. Okay, since v and a have the same sign, we conclude that the speed is increasing. All right, so here we've got the particle changes direction exactly once. So that means that v is changing sign. So we're probably going to need to look at a graph of v. And so I'm going to look on the window 0 to 6. I'm going to graph this thing. Oh, there it is. I see it changes exactly once. So I'm calculating the t value of this 0. And that looks like a good left bound. I'll use 6 as the right bound. Guess won't really matter. And can you read that for me? I can't see that far. 4.19. Okay, but we need more decimals. 5.19 what? Like that? Okay, equals the time that we're interested in. Okay, we want x at that. So x of I'm going to find this value by saying, okay, f of b equals f of a, and they told us x of 0 plus the integral from 0 to 5.1955223 of velocity. And okay, we really don't want to round off early. Early rounding, if it were to affect the last decimal of our answer and our answer were wrong because of that, that would be really sad, right? So we are not rounding until the very end. And that's why I'm holding on to all, looks like 8 decimal places of the t I'm interested in, because it's just not worth the risk. Okay, so I'm going to go over here. And I don't think I'm going to need it because I'm only doing parts A and B, but it's possible that you would need this t value for more than just this problem. And if that were the case, you would want to put 5.1955223, and we would want to store that in for, like, say, A. Okay, it's like, okay, I now know when you say A, I'm thinking 5.1955223. And then I'm going to do this integral. Okay, so that's going to be x of 0 is 2 plus math 9, get an integral. Integrate from 0 up to the time I'm interested in, which I had stored in A, of v of t dt. And v is y1 and then so the answer is equal to 14.135. Here we've got one from a multiple choice question, and looks like I just cut off the answers. If f is the antiderivative of this fraction that happens to have f of 1 equals 0, then f of 4 is what? Okay, well, we're not going to be able to find an antiderivative for this, at least at this point. It's not something that we can use u du for. We don't know how to use u dv yet, so what I'm going to do is I'm going to say f of 4 equals f of 1 plus the integral from 1 to 4 of x squared over 1 plus x to the 5th dx. Okay, so this is 0 plus, okay, I'll use math 9 again, from 1 up to 4. Okay, I'll use the fraction bar just to be safe, right? X squared divided by 1 plus x to the 5 dx. And it's looking like 0.376. I can't see the calculator is really small up on the screen. This is really far from me. I feel like this is not what I got last time, but still the integral expression I'm sure is correct. Okay, maybe I typed in something wrong. Maybe I didn't. And the last one I've got for you is another one of these multiple choice questions. If capital F is the antiderivative of this thing with f of 9 equals 1, then f of 5 equals what? Okay, this is definitely a calculator question, but I'm going to let you try this one on your own. So you're going to want to pause the video because in about 10 seconds it's going to come up with the answer. Alright, so I ran this integral on the calculator, and I got negative 3.150. Okay, and that's all I got for you today.